When you hear nuclear waste, what do you picture? Probably glowing green goo, barrels with warning symbols, and a sense of danger that lasts for millennia. We've been taught to see nuclear waste as humanity's most toxic, permanent garbage, a problem with no solution. But what if that's not the whole story? Science is about asking new questions. What if nuclear waste isn't just garbage? In reality, spent nuclear fuel is packed with untapped energy, like throwing away a cake after eating just one crumb. The story of nuclear waste is actually one of missed opportunities and a second chance for clean energy. It's time to look past the scary images and see nuclear waste for what it truly is. An incredible resource waiting to be unlocked. Let's get started. Let's go back to the 1960s, a time of scientific breakthroughs. At Argonne National Laboratory near Chicago, scientists saw nuclear waste differently. They realized that typical reactors use only a tiny fraction of uranium's energy. Most of it remains locked inside spent fuel rods. Throwing this away was like tossing out a log after barely burning it. They imagined a new kind of reactor, one that could use spent fuel as its own fuel. This wasn't just about reducing waste, it was about nearly eliminating it. Their vision, a closed fuel cycle, where nuclear fuel is recycled and reused until almost all its energy is extracted. This would mean hundreds of times more energy from the same material and far less hazardous waste. It was a bold, world-changing idea. The Argonne team set out to build a machine that could make this vision real. They wanted to turn nuclear waste into a powerful asset, and they were determined to succeed. Imagine a gallon of milk representing all the energy in fresh nuclear fuel. In today's reactors, we use just a teaspoon, then call the rest waste. That's what happens with uranium. 99% of its energy is left unused in spent fuel rods. The Argonne scientists saw this as a massive opportunity. With the right technology, we could tap into this untapped energy, turning our so-called waste into a gold mine. All the nuclear waste we've ever produced could become fuel for centuries of clean, carbon-free power. The challenge wasn't a lack of fuel, but a lack of the right machine. The Argonne team set out to build that machine. If we succeed, our garbage cans are actually filled with gold. That's the promise of advanced nuclear technology. The Argonne scientists designed the Integral Fast Reactor, or IFR. Unlike standard reactors, the IFR uses fast neutrons which unlock the energy in spent fuel. The IFR was built to solve the waste problem from the ground up. It included a recycling plant to separate out true waste and turn the rest into new fuel. This closed loop could extract nearly all the energy from uranium, about 100 times more than today's reactors. Suddenly, our stockpiles of nuclear waste become a vast energy reserve. Even better, the final waste from a fast reactor is much less hazardous, decaying to safe levels in just a few hundred years. The IFR didn't just shrink the waste problem, it transformed it. It's a fundamentally different approach to nuclear energy. The technology exists, it's just waiting to be used. The fast reactor could change everything. It's all about neutrons. Standard reactors use slow neutrons, which only split a tiny fraction of uranium, leaving most of it untouched. Fast reactors use high-energy neutrons, which can split the other 99% of uranium and even the actinides that make waste dangerous. Instead of creating long-lived radioactive waste, fast reactors burn it up for energy. They use liquid metal coolants like sodium, not water, to keep neutrons fast. The result? A reactor that eats nuclear waste and unlocks nearly all the energy in the fuel. It's not magic, just smarter physics. Fast reactors are a more complete, efficient way to harness atomic power. They turn our biggest liability into our greatest asset. The fast reactor wasn't just a theory. The Argonne team built one, the Experimental Breeder Reactor 2, or EBR-2, operating in Idaho from 1964. It quietly proved the concept for 30 years. EBR-2 used liquid sodium coolant, making it safer and more efficient than conventional reactors. In a famous 1986 test, it safely shut itself down during a simulated meltdown. No human intervention needed. The reactor powered the Argonne West campus, recycling its own fuel and shrinking its waste. EBR-2 showed we could turn nuclear waste into new fuel and make the final waste far less hazardous. It solved the two biggest problems, long-lived waste and reactor safety. By the early 1990s, the science and engineering were proven. The next step was a commercial-scale reactor to consume the nation's nuclear waste. The path to a clean energy future seemed clear, but then, unexpectedly, the project was stopped. The world wasn't ready for this breakthrough. The EBR-2's success was undeniable, but politics intervened. In 1994, just as fast reactor technology was ready to change the world, the US government canceled the program. The reasons weren't scientific. The reactor worked, the recycling worked, and the safety was proven. The problem was politics and fear, especially about nuclear weapons proliferation. Critics worried that recycling spent fuel could make it easier to extract plutonium for bombs. Supporters argued the process never produced pure, weapons-grade plutonium and was actually more secure. But these technical arguments were lost in the political debate. The fear of proliferation won out over the promise of clean energy. The EBR-2 was shut down, the teams disbanded, and the technology shelved. For decades, spent nuclear fuel was treated as a waste problem to be buried. A proven solution was left to gather dust. The world chose to bury a breakthrough instead of embracing it. For years, the fast reactor story seemed like a missed opportunity. But today, with climate change looming, the world needs every clean energy tool available. A new generation of engineers is reviving the fast reactor, updating old blueprints with modern technology. Companies like TerraPower are developing advanced fast reactors that can run for decades on spent fuel. Modular designs make them cheaper and faster to build. Supercomputers and new materials make these reactors safer and more efficient than ever. The mindset around waste is shifting. People see the value in turning liabilities into assets. These pioneers are building on Argonne's legacy, combining proven physics with modern innovation. The fast reactor's comeback is a story of persistence and rediscovery. Sometimes, the best way forward is to give a brilliant old idea a second chance. Today, we stand at a crossroads. We can keep fearing nuclear waste, or we can see it as the world's largest source of carbon-free energy. The material stored at power plants isn't garbage, it's fuel, ready to power the country for a century with no new mining or emissions. Building a fleet of fast reactors would be the ultimate act of recycling, turning our biggest energy liability into our greatest asset. The science is proven, the engineering is understood, and the original EBR-2 ran safely for decades. The only thing holding us back is perception. We need to let go of outdated fears and embrace the reality. The best way to solve the nuclear waste problem is to use a technology that consumes it. The fight against climate change demands bold thinking, and sometimes the answer is hidden in plain sight. The fast reactor teaches us to challenge assumptions and look for solutions where we least expect them. What we call waste could be what saves our world. It's time to unlock its potential. The future of clean energy is already here. Will we choose to use it?